All right, number 20, it's an absolute value inequality. It says we want our absolute value to be less than 19. In other words, less than 19 feet away from our zero. So here's our zero. Here's negative 19. Here's positive 19. We want to be somewhere in here. It says less than 19 feet away, not more than 19, less than. So we're going to end up being, maybe from here to here, because this 2n plus 1, so we're going to manipulate it. Wherever it lands, we need to be within 19 feet of the zero. So we're going to find the value for n that's going to make that true. Now, we simply start, because remember, this could be positive or it could be the negative 19. We don't know. So we're going to say, hey, when is that guy less than or equal to 19? And notice it's less than. Less than. This is an and situation. And we know it's an and situation because we're going to end up with some graph like this from here to there. Well, let's see. And so we have the positive piece, but we have to consider the negative part of that 2n plus 1, right? We got to consider that being less than or equal to the 19. This is how we set it up every time. Both equations, the two equations, are always going to be the exact same, the positive piece less than and the negative piece less than. The key is you have to decide whether the center is an and or an or. Since it's a less than, it's going to be an and. Now we simply solve it and we'll have our solutions. 2n less than or equal to 18, divide by 2, n is less than 9. That's one possibility. The other, we always will start this side by dividing by negative 1. Those will cross out. It'll end up giving us our 2n plus 1, the piece inside our absolute value. The inequality will always flip because we divided by a negative 1 here to start us every single time. And you end up with negative 19. So now we subtract 1, 2n greater than or equal to negative 20, divide by 2. The inequality does not flip because you didn't divide by a negative. So we need an n bigger than negative 10, but yet it needs to stay less than 9. So basically these spots, this is negative 10 right here, and this is 9. Those values for n, when you plug them in here, will stay within that 19 range. So the way we write this, start with your smaller number, negative 10, your bigger number here, 9, n in the middle. Alligators will eat towards the left, towards the bigger number, and this did have or equal to there. So n is basically between negative 10. You can see here's the n is bigger than 10, negative 10, right there. And here's the n is smaller than 9, which is right there. This is how we should write our and sentences. Some teachers might let you write this right here and then put the word and then write that right there, but I don't like it. Doesn't work for Cecil. Next problem. Same exact thing. Okay, we're going to solve this. Now this says, again, it's less than. So again, we're within. Here's your 0. We could be here at negative 14, 14. We're going to be in some range here between 14 feet, less than 14 feet away from our target of 0. So let's just solve this. Divide by 2, divide by 2. So we've simplified it now to the absolute value of 2n plus 3 has to stay less than 7. Now I can look at this being a positive or negative. Here's the positive, less than 7. So this is an and. I then look at the negative piece, less than 7. Always starting that way. Solve this guy. 2n less than 4, divide by your 2. You're going to get a messed up 2 there. Board isn't being nice today. Now on the other side, we're going to divide by negative 1. Goes away. Divide by negative 1. 2n plus 3. Ooh, you divide it by negative. What happens? Remember, it'll always flip. Negative 7. Now solve it. Subtract 3. Subtract 3. 2n bigger than negative 10. Divide by 2. What are we going to get? N bigger than negative 5. Notice I divided by a positive, so nothing flipped over there. So we're looking at n smaller than 2, yet bigger than negative 5. So we're going to put that in. Again, you could say n less than 2 and n greater than negative 5. I don't like it. I'm going to put my smaller number there, my bigger number here. Alligators eat towards the bigger number. Doesn't have an or equal to on this one, so there we're fine. You have n being bigger than -5, yet staying smaller than 2. So it's between -5 and 2. Any number there will satisfy our inequality. And finally, 22. We want it to stay bigger than -5. Now, this one, as soon as you see that, you should say, wait a second. This guy's going to be a positive number. How often is a positive number bigger than a -5? Always. No matter what you and I plug in here is going to work. If I plug in 3 plus 7 is 10, absolute value 10, that's going to be bigger than -5. If I plug -100 in there, -100 plus 7 is -93, but the absolute value of -93 is 93. That'll be bigger. So in this case, everybody works. All real numbers is the solution to number 22. We must pay attention to those special situations when we have an inequality, and this piece right here is a negative number.